I will tell you a big secret. The secrets of the 29th of February that exists some years and that doesn't exist other years. The years where it exists are the leap years. So, why do we have leap years? The answer is in astronomy, with the Earth's rotation and the Earth's revolution around the Sun. Namely, the Earth's self-rotation is 24 hours a day. This is a definition of the hour duration. It is a strict sense. But the Earth's revolution around the Sun, there is no reason that it is an integer. So, is it really 365 days a year? Not really. It is rather 365 and a quarter days a year. But how to manage 365 and a quarter days a year? Should we add a quarter of day each year? But this is not feasible on a calendar. We may add one day every 4 years. That's a good idea. And it's okay because if we multiply by 4, 365 plus 1 quarter, you obtain 4 times 365 plus 1. That is 3 times 365, 3 normal years, plus 366, 1 year with 1 more day. And here comes the leap day of the leap years. The leap years occur every 4 years, and by convention, it is when the number of the year is a multiple of 4. For instance, 2012, 2016, 2020. The non-leap years are 365 days long, and the leap years are 366 days long. The February month has 28 days during the non-leap years, but 29 days during the leap years. The 29th of February of the leap years is called the leap day. It doesn't exist during the non-leap years. And here is the Saturday, 29th of February, 2020, a leap year. But we don't have finished with the leap year's exploration. Let's go further. In fact, the year 1900 wasn't a leap year, though 1900 is a multiple of 4. Nor did the century years, except the year 2000, but it's another question. So, is there exactly 365 and a quarter days in a year? Not exactly. It is rather 365 plus a quarter minus 1 over 100 days in a year. How to manage 365 plus 1 over 4 minus 1 over 100 days in a year? You may subtract 1 day every 100 years, because 100 multiplied by 365 plus 1 quarter minus 1 over 100 is 100 multiplied by 365 plus 25 minus 1. And there are 25 multiples of 4 in a century. You may remove the leap days for every 25 leap years, because 100 multiplied by 365 plus 1/4 minus 1 over 100 is 25 multiplied by 4 times 365 plus 1, 4 years with a leap year, minus 1. It was decided to remove the leap day of the centuries because 100 is a multiple of 4, so that the centuries should be leap years. And what about the year 2000? It was a century, though it was a leap year. So is it exactly 365 plus 1/4 minus 1 over 100 days in a year? No, it is rather 365 plus 1/4 minus 1 over 100 plus 1 over 2000 days in a year. All we have to do is to restore the leap day for the centuries multiples of 2000. For instance, the year 2000. But let's finish with a bit theory. We did the rational approximations of the number of days per year. We started with an integer approximation, 365 days per year. It is the regular years that have 365 days. Then we made a first rational approximation, 365 plus 1/4, that is 1461 over 4 as a fraction, and it is for the regular leap years every 4 years. The second rational approximation is 365 plus 1/4 minus 1 over 100, that is 36,526 over 100 as a fraction. It is to remove the leap day every century. And the third rational approximation is 365 plus 1/4 minus 1 over 100 plus 1 over 2000. That is 730,521 over 2000. And that corresponds to the restoring of the leap day every 20 centuries. But what is the exact number of days per year? Is it exactly 365 plus 1/4 minus 1 over 100 plus 1 over 2000 days a year? Strictly speaking, no, it is not the case. But practically speaking, yes, because the next term deals with around 10,000 years, and it will happen many things in 10,000 years, including the change of calendar. And this is the end of Mathedu video about the leap years and the secrets of the 29th of February. If you loved it, don't hesitate to subscribe to our Practical Mathematics channel or to visit our official website mathedu.academy.